All right, finally, we are on 4.5, the last section in Chapter 4. Our test is a week from yesterday. Yeah, good. Okay, so this is the last section we're covering. This is going to utilize a lot of the techniques that we've learned in the previous sections. We're going to be solving equations, and we did a little bit of that in 4.2, but these are going to be a little bit more robust, a little more fun, a little bit more worthy of your time and effort. Okay, so an exponential equation is, first of all, a conditional equation. What is a conditional equation? I think we've had this terminology. Yeah, you said it. When there's a variable that we have to solve for. We solve conditional equations. Like if I have f of x equals 7, that's not a conditional equation. That's just a name equation, right? If I have 1 equals 1, that's another equation, but we call that an identity, right? So conditional equations are equations that we're trying to solve. We're trying to find the conditions, namely the values of x, that make the equation true. So here would be an example of an exponential equation because it has a variable in the exponent. And so the instructions are going to be to solve. So if you do this one, just kind of think about in your head, we've done this already. What do you think x is going to be-ish? 2 point something? Right, because 3 squared is 9, which is too small, and 3 cubed is 27, too big. So we could say right now that x is approximately 2 point something. And it's probably closer to what, 2 or 3? Probably closer to 2, yeah, because 11 is closer to 9 than it is to 27. Now, unless we have a calculator, we're not going to be able to find the value, okay, unless we have log tables or we know, Taylor polynomials or something. So we need to be able to solve that equation and be able to isolate x so that we can solve it, okay? So we've already done a little bit of that. Let's do it on example 1. We already know it's going to be 2 point something. So if we were to then solve for x, what would be the first thing y'all would now hopefully instinctively do? We got to solve for x, right? Currently x is trapped in the exponent, so we need to undo exponentiation. Square root? Log? Yeah, logs. Yeah, if I take the square root of both sides, someone mentioned that would be raising both sides to the 1/2 power. That doesn't get the x out of the exponent. So when you have an exponential equation and it's not something where you can get the bases the same, like we can't write 11 as a power of 3 very easily, we need to undo the exponentiation by inversing it with the log. So we can write it like this. We'd have log base, what base would y'all use? 3? Yeah, 3 would be fine, right? Because it's exponentiation base 3. So you take log base 3 of both sides, and this is what it looks like. It has to go in the front, so you can't just like tag it on the right-hand side of 11, right? And so now, if we simplify that, what becomes of the left side? What is log base 3 of 3 to the x? It's x. And we get an answer over here, log base 3 of 11. So if I ask you to evaluate log base 3 of 11, you would ask yourself, 3 to what power is 11? And you'd say it's about 2 point something. So we know that this is about 2 point something, and there's the squiggles. But if I want to evaluate this, what do I need to do? Assuming that we don't know our calculator's secret option of like typing in our own base, what do we have to use? Changes, right? We have to change the base because our calculator directly, without the math print option, can only handle base e and base 10, right? So here's what we'll do. We'll just convert it, right? That's the natural log of something over the natural log of something. Which one goes in the top, the 11 or 3? The 11, good, over 3. So this is how I'm going to expect you to give your answers. But if it's a multiple choice question next Thursday, I could really do either one of those. I probably wouldn't put it in terms of base 3, but I might. Okay, now we have something we can type in. So now go to your calculator and get in the habit of using the horizontal division bar. So alpha y equals, remember. And then we type in ln. Notice it opens the parentheses. So you do want to get in a good habit of closing it. And then directional pad, go to the bottom. Natural log of 3, get in the habit of closing it. I like to click to the right so that I can see the actual expression. And it should pretty much match, minus the parentheses and the font size and color, what we have written on our paper. Hit enter, and there it is. So underneath there, we'll just put x equals, you don't have to put a squiggles here, 2 point, and then how many decimals are we responsible for? 3. So I like to truncate to 2.182 or 2.186. Now, the only time you would need to put squiggles if you're stopping or rounding is if you then said that that is approximately 2, okay? Because you don't want to say 2.182 equals 2, because that's not true. But anyway, we'll just leave it as a 3-decimal approximation. So there you go. We had a way to get the x onto the ground floor systematically so that we can isolate it, which is solving for it, and that involves logs. Okay, well, this method here required the logs because 11 was not a beautiful perfect power of 3, okay? But we're going to jump back and review that method first, because it should be the method that you first consider when you're trying to solve an exponential equation. So solving by the GTBTS. I've already kind of shown this to you in the previous section. That's just the name I give to what getting the base is the same. Getting the base is the same. So here's what it says. If b to the x equals b to the y, that is, you have the bases b the exact same, since exponential functions are 1 to 1, that means that the exponents have to equal each other. Okay, we've done this already. Let's try it out. Example 2. The instructions now specifically say to solve each of the following by the GTBTS method. All right, so if it says that, you don't have to use logs. You certainly are welcome to use logs here, but if you can get the bases the same, you don't really need a calculator, which is kind of what is nice about this. Okay, so we have a base of 9 and a base of 27. The bases are not the same right now, are they? So you have some options, right? You either try to write 9 as a power of 27, no thank you, or write 27 as a power of 9. Ooh, well, 9 to the first is 1, 9 to the second is 81. Oops, too big. So that's not going to be real easy to do either. But can I write both of those in terms of some third-party base? 3, right? Yeah, okay, good. So let's do that. So inch by inch, it's a cinch. Remember, you work straight down, you show all of your steps. So I'm going to put parentheses where the 9 was, and I'm going to put parentheses where the 27 was. And I'm going to replace those with powers of 3. So 9 is 3 squared, 27 is 3 cubed. All right, that's step 1. And now we use our rules of exponents. On the left and right, when we have exponentiation, it turns into what? Multiplication, one rung lower. So we get 3 to the 4x. And over here we get 3 to the, is it 3x minus 1 question mark? No. 3x minus 3. Yeah, if you're going to do it as 3x minus 1, you have to have parentheses around the x minus 1. I would probably just say, hey, y'all are at the point now where you can just distribute 3x minus 3. So just handle the distribution somehow, either with parentheses or just distribute as you write it. Okay, and now, since we have 3 to the something equals 3 to the something, this little thing says it's a theorem, right? This says then I can let x equals y. So really, at this point, we should have some transitional word like so, or therefore, or thus, or ergo, or consequently, 4x equals 3x minus 3. When it's a result of a theorem, that's kind of a nice transitional word. Otherwise, if you don't write that, someone's going to be like, well, what happened to the bases? And you're like, they divided out? No, they didn't. Okay, it's a consequence of the theorem. Okay, so now that we've done that, it's like we're back in Algebra 1, huh? Algebra 1. We need to get the x's by themselves, so red rover, let 3x come over. And we get 4x minus 3x, which is 1x, equals negative 3. Are we done? Oh, yeah. Algebra 1 was kind of boring, right? Because the problems were so short. They ended almost before they started. Darn, right? But now, this is just the tail end of an awesome problem that we solved by getting the bases the same. Okay, is it right? We can check, right? You can trust your method, that's great, but it's kind of good to check. So let's go ahead and check with the calculator Medora. So go back to your calculator Medora, or just your calculator, or your Medora, whatever you want to call it. And here's an easy way to do it. On your calculator screen, go hit negative 3. Gently hit it. Don't break the calculator. Negative 3. Not minus 3. Use the negative button. And then hit stow, which is right above the on the left-hand side. It'll have an arrow. And then up there to the right of alpha, hit the X button and hit enter. Okay, why would you want to do that? Well, now you don't have to type in -3. You can just keep hitting X. Now look at this. If I hit XX, that should be what? +9, right? There you go. If I hit XXX, that should be not in this class, right? We don't do that kind of stuff in this class. Triple X stuff, that's pornography. We'll stay away from triple X. Okay, so let's go ahead then and plug in these expressions. 9 to the 2x, okay? 9 caret dos equis. We should probably not call that dos equis either. Just 2 times x, okay? And boom, we get that number. Yeah, way to go. Yeah, now let's try the other side. 27 caret, and notice I'm in the exponent, so I don't need parentheses around it. It's just x minus 1. That's what math print is. It's nice. It's kind of like how you have it written on your paper. If I hit enter, and it is the right value, what value should I get? Same. Yeah, do I get same? Yeah, same. Way to go. So we're done. Right. We're awesome. I thought you were going to say awesome. Or we are correct. But unfortunately, we are also done with this problem. Hey, how about big D and big D, right? How about that? Yeah. Who cares? They're in first place in our division. But yeah, who cares? Yeah. You're not a Cowboys fan. That's like saying you're not an American, man. No, that's okay. It's like I love America, but I don't love the Cowboys. I love America, but I don't love Trump. Whatever. It's all the same thing. Yeah. It's okay. I love Drew Brees, though. I love Drew Brees. Yeah. He's the GOAT, right? Yeah. Okay. Anyway, he's pretty good. Yeah. He got stifled last night, though, by Big D. Okay. Oh, he has a cute little son. Right. Yeah. Okay. So on part B, it says the instructions say to solve it by the GTBTS method. So what's the base on the left? +1/5, right? The 100 is not the base yet. It's 1/5 because that's what has the exponent. Do we have a base on the right? Not really, because it's 4 to the first. That's not even a variable, so we just have a number. So when you're trying to get the bases the same, you're going to want to try to isolate the part that has the variable in it. It's kind of like if this were algebra, that would be like x. So if it were 100x equals 4, what would you do to solve for x? Get rid of the 100 by just erasing it, right? No, by dividing through by 100. So that's the same idea. You want to isolate the variable portion. So let's go ahead and divide both sides by 100. Now we're past the step or past the age where we do that. We don't need to show that, okay? We're past that. If you still need to do it, that's fine. It isn't incorrect. But when you work straight down, and the next line doesn't have 1/25, but it has 400ths, that is enough to imply what you've done. Okay, and that's why I'm trying to teach y'all to, when in doubt, don't leave it out, show it. Okay, so I've isolated the variable part, but what do you notice on the right-hand side? You want to learn to simplify early and often, so as you go. 4/100ths is the same as 2/50ths or 1/25, yeah. Now, that is significant because we have 25 now and 5. And those can be written in terms of powers of each other. So here you have the option. You can either write both sides in terms of 1/5, or you can write both sides in terms of 5. Who wants to stay with the fraction? Okay, good. So we'll go with 5 then. So on the left, if you don't like the 1/5, you can call it 5 to the what? -1. Very good. And on the other side, you can go straight to 5 to the what? Hopefully. -2. Yeah, if you need to show more steps, 1/5 squared, and then bring the 5 to the top, that's fine. But we can follow that. 1/25 equals 5 to the -2th power. Okay, and now on the left, I'd have to multiply. So I get -x divided by 4 equals 5 to the -2nd. Have we gotten the bases the same? We did. So now we could say, so -x/4 or negative 1/4 x, whatever you want, equals negative dose. And now again, we're like back in Algebra 1, maybe like middle of the first semester. What do we do to solve? Multiply both sides by 4 would be good, but then we'd have a negative still. So how about multiply both sides by negative 4, and you get negative 4 times negative 2 is positive 8. So if we can get the basis the same, we can get relatively nice answers without using the calculator. Now let's go ahead and check it. We'll store x as 8 now. So go back to your calculator and just use a different variable to store now. We'll put 8 stow as x, and then hit enter. And now we have a new value of x. So now you can type in the left side 100 times, and again, if it's written on the paper one way, you should try to do it on the calculator that way. So parentheses, 1 divided by 5, close parentheses, caret, and then we'll just hit x divided by 4. You don't have to worry about typing in an 8. 8 wouldn't be too bad because it's one keystroke. The previous problem was a negative number, so it would have taken 2 keystrokes each time. We get 4. And of course, if we plug it into the right side, there's nothing to plug into. We get 4. Does 4 equals 4? Yeah, it does. So again, that means we are correct. It means we are awesome. It means we are done with this problem. All right, kind of fun, right? Better than Sudoku? Yeah, I think so. Yeah. Hey, what do you do for fun? I solve exponential equations by GTBTS. Cool, bro. All right. Okay, smarty britches. Go ahead and do this one on your own. I'll let you do this one. Yeah. You have the knowledge. You just now need to do the same thing we've been doing to this wonderful looking problem. When in doubt, show more steps than leave steps out. All right, if you're stuck, 1/4 can be written as a power of. You got 4, 16, and there's an 8 over there. The 8 kind of messes it up, because otherwise you could write it in powers of 4. But 4, 16, and 8 can all be written as powers of what? 2. So that's what I would recommend. Go through and see if you can write everything as a power of 2, and then you can use your rules of exponents to get everything together. Because then your goal is 2 to the blob equals 2 to the blob. Therefore, the blobs have to equal each other. Blob equals blob. So true. Jingle bell. All the way. If you happen to finish and get an answer, you can check it with the calculator. Or you can check it by plugging it in by hand and evaluating both sides. But I think you know how to do that if you've already solved for x. All right, let me see if I can catch up with y'all. We've already kind of done the initial investigation or analysis. You look at all the numbers that are there, 4, 16, 8, and 2, and you try to find, okay, is there anything we can do to get them all the same? And yeah, if the 8 wasn't there, we can write everything, well, the 2's there too. So yeah, let's just go ahead and put it all in terms of 2. So 1/4 would be 2 to the negative second. And I'm going to keep the parentheses there just to kind of work on each factor by itself. All right, so this one, I'm going to leave the x plus 4. The cube root of 16. 16 is 2 to the what? 4th, so that should be 2 to the 4 thirds. Good. All right, and then over here, yonder, we have 2x minus 1 as the exponent. The bottom is 2 to the first. That's already there. I'll just put a 1 there maybe. And then the 5th root of 8, well, let's see. 8 is 2 to the third, so then that would be 2 to the 3/5. Yeah, sweet. Okay, that's step 1. That's probably the hardest part because it required the inside of putting it in terms of 2. Now it's just kind of like computation. At this point, it's not like thinking of strategies. It's just implementing properties. So I would leave this one over here, 2 to the negative 2, because I have to do something to this one first before I can combine them. And, of course, what do we do with those two? Multiply them. So let's distribute as we go. So that's 4 thirds times x. And I'm going to write this one as plus 4 thirds times 4 is 16 thirds. Because remember, that's the same as 4 over 1. So you just multiply straight across. And let me rewrite 16 thirds. 16 thirds. Okay. And then boom. So notice that it's part of the exponent. The goal is that you're trying to get rid of parentheses ultimately, right? So you just have 2 to the something, 2 to the something. Now I have some options over here. I can either distribute the 2x minus 1 to both exponents, work from the outside in, or I could try to tidy up inside the house before I bring guests in. What would you want to do? Tidy up inside, right? We don't want to be embarrassed. But if you let the guests in first, maybe you can talk the guests into helping you tidy up. Yeah, they probably wouldn't come back again. So, yeah, let's clean up inside first. So, what would we do there with the 3/5 and the 1? They're dividing, so we subtract. What is 3/5 minus 1? 1 is how many fifths? 5/5. So 3/5 minus 5/5 is negative 2/5. Muy bien. Okay. Inch by inch, it's a cinch. Okay, so now on the left, we don't have exponentiation anymore. We're down to just multiplication. So what do we do with these exponents when we're multiplying and the bases are the same? We add them. Good. So this is 2 to the. Now remember, we can only add like terms. So the 4 thirds x is an x term. We can only combine the negative 2 with the 16 thirds. Okay, so we need a common denominator. So negative 2 is how many thirds? Multiply by 3 over 3, you get negative 6 thirds, right? Negative 6 thirds. So what is 16 thirds minus 6 thirds, or 16 minus 6? 10, right? So we get positive 10 thirds. This is where all that working with fractions at the beginning of the year is paying off. If you still need to go off to the side to do that, that's where you do it. Now notice the parentheses are gone from the left. Because I can only combine like terms. Like it's almost writing it like this. Negative 2 plus 4 thirds x plus 16 thirds, right? I can only combine like terms. And because the 4 thirds has an x, I can't combine the constant with it. Yeah. It just looks funny because we didn't have a plus sign there, but that's what we're doing. Okay, good question. Yeah. Over here now, we have to distribute. So that becomes negative 4/5 times x. And then a negative times negative is positive 2/5. And so far it looks good, right? Are we where we wanted to be? Yeah, we have no more parentheses. We just have 2 to the blob equals 2 to the blob. And therefore, or so is a good word, the blobs must equal each other. So 4 thirds x plus 10 thirds equals negative 4/5 x plus 2/5. And finally, after all that work, we land back inside an Algebra 1 class. Maybe late first semester. I don't even know if y'all worked with fractions like this in Algebra 1. If you didn't, you were probably robbed of an experience. So at this point, we have two options. We can either embrace the fractions. We love you fractions. We'll just keep working with you fractions. Or you could be like, we eschew the fractions. We don't like them. We're going to get rid of them. We're going to excommunicate them. We're going to banish them to the island of Elba. What do you want to do? You want to embrace the fractions or get rid of them? Get rid of them. Okay. I would say if you like working with fractions or if you're comfortable working with fractions, get rid of them because you don't need the practice. But if you don't like working with fractions, you should probably work with them so you get the practice, right? But I know y'all are good, so we're going to get rid of them. So here's how we get rid of them. We're going to put parentheses around both sides because they are terms. I need to multiply both sides by something that when I distribute will divide out with both denominators. That's what we call the LCM, right? Or LCD, either one. At least common multiple, least common denominator. What is the LCM of 3 and 5? 15. It's their product because 3 and 5 are co-prime, right? Co-prime. So I'll multiply over here by 15, multiply over here by 15. And now if we distribute 15 thirds, do not go 15 times 4 first, right? That defeats the purpose. Go 15 divided by 3 is 5, and then 5 times 4 is 20. So we get 20x plus 15 divided by 3 is, again, 5. 5 times 10 is 50. Yes, yes? Divide, then multiply. Go small before you go big. Okay, on the right side, multiply, distribute, but then divide first. 15 divided by 5 is 3. 3 times negative 4 is negative 12x. Distribute to the next one. 15 divided by 5 is 3. 3 times 2 is 6. Divide out and then multiply. All right, now we're working with integers, which feels nicer. We're going to end up with the same answer. It's just the fraction is not going to manifest until the last step up here for the last step. Okay, so now we bring the x's. I'll bring them over to the left, and I'll bring the 50 over to the right. So let's see, 20 plus 12 is 32. So we got 32 x's. And over here, 6 minus 50, or negative 50 plus 6, is negative 44. Yeah. And we're almost there. We are almost there. Now we just divide both sides by 32, and we get x equals negative 44 over 32. And we feel like we should be done, but thank goodness we're not. Right? It's like we get an extra day in the Disney park. We get one more thing to do. Yay. Even though we're out of money. What? Simplify. Good. Yeah. What's the greatest common factor now of 44 and 32? 4 would work, right? Remember, if you don't know what the greatest common factor is, just keep dividing out until you have no more. So if you can't find the biggest one right away. But yeah, they're both multiples of 4. So that's going to be negative 11 over 8. And 8 and 11 are what? Co-prime. So it's simplified. Yeah. Okay, so how fun was that? That's a rhetorical question. You don't have to answer it. Okay? Because we know the answer. Exactly. Yeah. Notice that if you try to go straight from here to here, you're going to choke, right? That's eating the elephant in one big bite. No, don't do that. Okay? Teeny little bite by teeny little bite. Inch by inch, it's a cinch. Work on the factors first and work on getting rid of parentheses, okay? And then once you get the bases the same, it's kind of like a brand new day, a brand new problem, Algebra 1. Let's check it, huh? Let's check it. This time, I know we're right. So the only reason I'm checking the answer now is to see if the calculator is as smart as we. Right. Is that the correct way to say it? As smart as we or as smart as us? That's wrong. No. The correct way to say it is as smart as we. Okay? Yeah. Now, that sounds funny because normally we say what Thomas said, as smart as we are. Right. Normally we put the verb after that. But you don't need the verb after that. It's understood. So when you just say as smart as we, it kind of sounds pretentious, right? And so you say either as smart as we are, which sounds better, or you say as smart as us, and that just sounds bad. Because then if you add the verb to the end of that, it sounds as smart as us is. Right? So when y'all speak, do you ever go through that test, that verb test at the end? Yeah, that's how you know which one to use. Good. So let's see if the calculator is as smart as we are. Okay. Yeah, you don't want to be that guy. All right, so negative 11 divided by 8. Oops. Try that again. Negative 11, hit it twice, divided by 8. And I'm going to store that as x. Okay, so what that does is that liberates us from having to type in negative 11 divided by 8 every time there's an x. We just use the x button, right? If you're interested, it's negative 1.375. Cool. All right, and where do we go? We go up back to the very, very beginning, to the top. And we type it in, hopefully, as we see it. So parentheses, alpha y equals, and we get a 1 divided by 4, close parentheses, open parentheses. The cube root. Oh, man. Do y'all know how to do cube roots? What's that? Math 4? Okay. I don't really use that, but yeah, math, okay, look at there. If you go down to math 4, that's a built-in cube root. If you ever want to take a different root, that's called the x root. You have to type the number of the root in first, and then it'll take it as the root. So here's what I would suggest. I don't like typing in roots at all. So I'm going to do it this way. I'm going to say it's 16 raised to the 1 divided by 3rd power. Okay? And then I'm going to close parentheses. I feel better doing it that way. Okay? 16 to the 1/3. And then I will raise that caret to the x plus 4th power. So every time I see a radical, that's what I'm going to do. I'm going to just replace it with a fractional exponent. Okay, I hit enter. And I get, yeah, 2.828. That's kind of what I didn't know it was going to be. But yeah, did everyone else get that? Okay, so that's what we should also get on the right-hand side. Let's see. Parentheses, alpha y equals. We get the 5th root of 8. Okay, so there's no built-in 5th root button, so let's just call that 8 to the 1 divided by 5 power. And then in the bottom, we'll call that 2. And then parentheses, and then we'll raise that to the 2x minus 1th power. Okay, double check, triple check, how does that look? Yep, perfect. So we should get the same answer. Yeah. Way to go, calculator. You are as smart as we is. Yes, well done. Okay, see, fun. You didn't realize you're going to have this much fun on a Friday, right? Yeah, you got out of bed and you're like, man, I wish it was the weekend. But now it's like, you would have missed this, right? Don't wish your life away. Savor every single little moment, especially the math ones. Okay, so this is going to be the first method that you should probably attempt when you're solving an exponential equation. You have a variable and an exponent. Try to see if you can get the bases the same. Now, you might be able to tell right away, like in the original one here, that we can't write 3 and 11 as a power of a common base. That's going to be when you need to use a heavier tool, right? And what's that heavier tool? If you can't get the bases the same, you need to use logs, right? With the change of base, you need to use logs. Okay, so it says solve the following equations. Give a simplified exact answer and a 3-point estimation, and then verify on the calculator. So, how do we know this is, first of all, an exponential equation? It has an e, but that's not why. There is a variable where? In an exponent. That's what makes it exponential. Okay. The base is e. That's an irrational number. Do you think you're going to be able to write 30 or 9, or 30 divided by 9, which is not really even a pretty number, as a power of e? No, I don't think I'm going to be able to get the bases the same. When you have numbers in e, there's no way to do it. So we're going to need to bust out the logs, right? So what logs should we use on both sides? Up here on the original intro, we used base 3 because it was base 3 on the exponential, but we turned it into natural log at the end anyway. So what I would recommend is, regardless of what your base is, whether it's 3 or 5 or 7, since you're going to end up with natural logs anyway, you should just use the natural log, okay? So that's our tool. We're going to use, let me write this out here, we're going to use natural log, okay? So what we do is we take the natural log of both sides. We'll call this the left side and the right side. So when you take the natural log of both sides, you do not change the solution because it's like a balance, right? You learn that in Algebra 1. If you do something on the left, you got to do something equivalent on the right, where it's out of balance. Okay, so let's do that. On this line here, we get the natural log of the quantity, 9e to the 2x. And again, parentheses are not necessary over there, but I'm going to go ahead and put them because it's going to help you kind of keep track or see layers. All right, so that's your first step. Now, what can we do? Do the natural logs divide out? No. Should we e both sides? E to that, e to that? No, that'll take us back where we started, right? If you have a journey, it doesn't really help to take one step forward and then one step back, and then one step forward and one step back. I guess you can. That kind of at least gets you moving, right? In golf, before you swing, they call that a waggle, right? It's kind of getting loose there, right? We don't need to do that. We're already loose. So what can I do? What should I do? Yeah, I can move the 2x. Can I move it out? Oops, I erased it. Can I move it out front right here, right now? No, why not? That 2x is only associated on what? The e, not the 9. So, did we learn any properties? Like, I don't know, like maybe like 3 of them or something? Expand. There you go. There you go. So you're going to take the natural log of both sides. Let me move this up a little bit. So once you do that, then you're going to expand. Expand. Okay. So on the left, we have 2 factors. So it's the natural log of 9 plus the natural log of e. And then you can either leave the 2x there, or now you can bring the 2x to the front. There we go. And on the right, we get the natural log of 30. Now that was a nice step because notice it brought the 2x to the ground floor. It's out of the exponent. And now look to simplify. What is the natural log of e? It's 1. Yeah, the natural log of 1 is 0, and the natural log of e is 1. Okay, so that becomes 1 times 2x, or just what? 2x, okay? So I'm going to do that on a separate line. Now notice if you would have, in this case, left the 2x up there, you could have gotten to the same thing, right? Because natural log of e to the 2x, since natural log and e are same base, it would just be the blob. They undo each other, but well, you get the same answer. Okay, so now that we have this, we're really back in Algebra 1 again, right? Because the natural log of 9 and the natural log of 30, as ugly as they look, don't say that out loud. I already did. I'm sorry. I hope they didn't hear me. Sorry, guys. It's opposite day. You're beautiful, actually. Dang, now that means they're ugly again because it's opposite day. I'm not going to win with these guys. Anyway, natural log of 9 and natural log of 30 are just what? Numbers or variables? They're numbers. They're numbers. The natural log of 9 is a number. The natural log of 30 is a number. How do you know that they're numbers? They don't have a variable, right? In fact, let's go over here to the left, the calculator. What is the natural log of 9? I don't know. Is it ln of 9? It's 2.197224577, blah, 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 blah. Which one is better to use? 2.197224577, blah, 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 or natural log of 9? Natural log of 9, okay. So it's just a number. So how do we solve when we have numbers and x's to the first? We get our numbers on one side and our variables on the other, right? So let's go ahead and subtract the 9x from both sides. So we get 2x equals the natural log of 30 minus the natural log of 9. There you go. And now all we have to do is divide both sides by 2. So you get x equals the natural log of 30 minus the natural log of 9 all over 2. Beautiful. So are we done? Well, we could be, right? We have x equals a number. We have x equals a number. So we could be done. We could be done. But if you remember what I said yesterday, once you get to your answer and you have logs in it, you should learn to do what at the end? No, just play, right? Let's play. Let's play with the logs. Coochie, coochie, coo. Okay. Well, let's see. What can we do? Yes, very good. I can condense the numerator. I can make that the natural log of 30 divided by 9. Now, if I did that, is that nice integer? 30 divided by 9? No, it's not. But does it simplify? Yeah, they have a common factor of 3, so I can call that 10/3. All over 2. Does that look better than the original version? I don't know. It looks like a complex fraction. So here's what you could do to make it look not like a complex fraction. Dividing by 2 is the same as multiplying by 1/2. So you can call that 1/2 natural log of 10/3. So that's another version of it. Or let's go ahead and expand the numerator now that we simplified it. That's the same as the natural log of 10 minus the natural log of 3 all over 2. Now that looks like a little bit better than what this one was. Okay? Or you could pull the 1/2 out front and say it's times the quantity natural log of 10 minus the natural log of 3. You could do that, right? Yeah. Or you could distribute the 1/2, right? 1/2 natural log of 10 minus 1/2 natural log of 3. Ooh, how's that looking? Yeah, it looks pretty good. Hey guys, what can we do with the 1/2 now that are out front? You get back up there. And we can make that the natural log of 10 to the what? 10 to the 1/2 power. Also known as what? The square root of 10. Oh yeah. Minus the natural log of 3 to the 1/2 or square root of 3. OMG. I like that version. So look at this. If you got this answer on a test, on a multiple choice, and that was not there, but this answer was there, would you know that that was equivalent just by looking at it? Probably not. But once you start doing what? Playing with it, you can get there. Yeah. So I always enjoy making answer choices for log equations. Yeah. As does, if you go on to take calculus, as does College Board. College Board, they love to play with logs. Okay? So just make sure that you understand that there are very different equivalent versions of the same answer when logs are involved. And that's what makes logs really, really useful. But that's also why most students hate logs, right? Because like, God, there's so many. How do you remember what, why, right? But if you play, it's fun, right? And you reinforce all of those properties. Okay, cool. Should we check it? Should we test? Let's check. Let's come over here, and I'm going to type in the natural log of the square root of 10. Make sure you click to the right so you're outside the radical. Minus the natural log of the square root of 3. I'll hit enter just to see what that's equal to. It's 0.601. So if you already have it typed in, now you could just hit stow and it'll recall the answer from the previous line. We'll store it as x. Okay? Oh, and just for kicks and giggles, let's come over here. The original one we got, alpha y equals natural log of 30, close parentheses, minus the natural log of 9, close parentheses, all divided by 2. I knew it was the same. There it is, right? So it is the same. We already have it stored as x, don't we? Stow as x. Okay, so now we come all the way back up here to the top, and we just type in 9e. So remember to get the e to the power of, you hit second ln, and then we just put 2x. That's the left side. If it works, because I've stored the value, it should be really, really close to 30. It may have decimal overrun, so it may not hit 30 right on the head, but you'll know if it's right. Hey, it did it! If it did like 29.99999, I'd be like, yeah, it's close enough. Or if it did like 30.00001, I would be like, that's close enough. Sometimes when you're using those irrational numbers, it loses some decimal accuracy in the process. But it's 30, so what does that mean? We win. Yeah, we win. That means the calculator is as smart as us is. And I think that's a fantastic place to stop for today. For the week, actually, right? For us, you can continue the fun next period in your next class. Just make it look like you're doing English or whatever while you're doing these math, right? And if they ask what you're doing, just say, better than Sudoku. Yeah. Okay, enjoy the rest of your National Moose Day. And it's not like moose with antlers or like hair mousse. It's like chocolate mousse, like pudding. Mm-mm, 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 mm-mm.